Good morning and Jai Hind dear students. Today I am going to start the third module, and in this module we will be talking about indicators, what are indicators, types of indicators and how they are used for identifying whether a given solution is acidic or basic. Along with that we will be also discussing in brief about the differences between acids and bases. Now coming to indicators. Indicators are the substances used for identifying acids or bases. They are also called acid-base indicators. We can also define those substances that changes its color when added to an acid or a base is called indicator. Now coming to types of indicator, indicators can be categorized as natural indicators or artificial indicators. So the indicators which you are seeing over here are natural indicators. So natural indicators are turmeric, litmus, China rose petals, red cabbage juice. Now coming to artificial indicators or commercial indicators, we can say commercial indicators are phenolphthalein, litmus paper and or litmus solution and methyl orange. Litmus as an acid-base indicator. Now litmus is a natural dye and it is extracted from lichens. You had studied about lichens in the chapter nutrition. Lichen is a kind of symbiotic association between a fungus and an alga. Alga being an autotroph, it synthesizes its own food through the process of photosynthesis and supplies it to the fungus. Fungus in return absorbs water and minerals and supply it to the alga. So it is a kind of mutually beneficial relationship, and litmus is extracted from lichen. Now it is in distilled water or in neutral medium, the color of litmus is purple. In acidic solution its color is red. In basic solution its color is blue, and litmus is available in the form of solution and also in the form of strips of paper called litmus paper, generally as red litmus paper and blue litmus paper. So you can see here we have this strip of paper, this is red litmus paper and this is blue litmus paper. Now what happens if we dip blue litmus paper in a solution, and if it becomes red or turns red, then we say that the solution is acidic. So we can say in acids blue litmus paper turns red. Similarly, if we dip a red litmus paper in a basic solution or in a base, then the red litmus paper turns blue. So we can say the red litmus paper in a basic solution turns blue and it is a basic solution. So in this way, we can identify the types of solution, whether the given solution is acidic or basic. Then coming to turmeric as an acid-base indicator. Turmeric can be used for identifying acids or bases. Generally, turmeric is yellow in neutral solution. Turmeric is also yellow in acidic solution, but in basic solution, turmeric turns red. So you have to remember that in basic solution or when added to bases, turmeric always turns red. Then effect of turmeric on different types of solutions. For example, if we talk about lemon juice, the effect of turmeric on lemon juice, there will be no change. We can say the solution is either acidic or neutral because the color has not changed. Orange juice also, there will be no change in turmeric solution and we can say the solution is acidic or neutral. Vinegar, since it is also acetic acid, it contains acetic acid, and in acid we know that turmeric does not change its color, so there will be no change. The solution is acidic or neutral. Milk of magnesia, that is magnesium hydroxide, it is a very strong base, and turmeric solution in milk of magnesia or magnesium hydroxide changes to red color. So we can say that it is a basic solution. Baking soda is NaHCO3, sodium hydrogen carbonate. So turmeric in baking soda also changes to red. We'll say it is a basic solution. Lime water is calcium hydroxide. It contains calcium hydroxide or slaked lime. It is a base and therefore the turmeric will change to red and we say it is a basic solution. Sugar, no change. We can say it is acid or neutral. And common salt, no change since it is a salt, therefore turmeric will not show any change. Now coming to China rose as an acid base indicator. China rose as an acid base indicator. So China rose extract can also be used as an acid base indicator for identifying acid and bases. China rose indicator in water, that is in neutral medium, is pink. China rose indicator is magenta or dark pink in acidic solution. You have to remember that China rose indicator is magenta in acidic solutions or dark pink, and China rose indicator is green in basic solutions. Then China rose its effect in different solutions. So you can see here this table, you can see like in shampoo, which is a dilute solution, initial color will be milky and final color it changes to green. Lemon juice, it is dirty white and changes to magenta. Soda water, colorless, and the color of China rose on adding to it changes to green. Sodium hydrogen carbonate solution, it is colorless, and on adding China rose it turns green. So these are the different solutions where we can test China rose and how it behaves, how it is changing the color, whether it is changing or not. Then coming to, in brief, reaction with indicators, that is synthetic indicators or artificial indicators. For example, when we talk about phenolphthalein, it is also a synthetic or artificial indicator. In acid, it is colorless. In neutral solution, phenolphthalein will become faint pink, and in basic solution it will become dark pink. What about methyl orange? Methyl orange in acidic solution is red. When in neutral solution, methyl orange becomes orange, and in basic solution it is orange. Then coming to litmus paper or litmus, as in acid solution, blue litmus changes to red, and in neutral solution no change in color, and in basic solution red litmus turns blue. Then coming to differences between acids and bases. So when we talk about acids and bases, we can say what is the difference between acids and bases. So main difference, we can say acids are sour in taste, whereas bases are bitter in taste. Acid give a corrosive touch, bases give a soapy touch. Acid turn blue litmus red and bases turn red litmus blue. Acids release hydrogen ions when dissolved in water, and bases release hydroxyl ion when dissolved in water. You did not remember this. You have to study this in higher classes, that which are the substances or which substances are said to be acid. If they release H plus ion or hydrogen ions, then they behave as acid, and when the substances release hydroxyl ions or OH minus ions when dissolved in water, then they are called bases. Second, another difference we can give, acid react with metals, and when they react with metal they form a compound and release hydrogen gas, but bases do not react with metals so easily. What about some of the examples, as we had discussed earlier also? Hydrochloric acid is a very strong acid. Sulfuric acid H2SO4 is also a very strong acid. Nitric acid is a very strong acid. Phosphoric acid is also a very strong acid, and boric acid, etc. Acetic acid or organic acid, these are some of the examples of acids. In these, some of them can be strong acids and some of them can be weak or organic acids. What about bases? Sodium hydroxide is an example of a base. It is a very strong base, soluble in water, also called alkali. Potassium hydroxide, it is also a very strong base, soluble in water, also called alkali. Calcium hydroxide, also called slaked lime. It is a strong base but not as strong as sodium and potassium hydroxide. Then magnesium hydroxide, MgOH2, also called milk of magnesia, it is also a strong base. So these are some of the example of bases. Now I will stop here, and in the fourth module I am going to discuss about neutralization reaction. What is neutralization reaction, and what are the products formed when acids and base they react among themselves, and how neutralization reaction plays an important role in our day-to-day lives. In addition to that, we will also be discussing in brief about the salts in module 4. Thank you and Jai Hind.